In this video, we are going to use divisibility tests to test this following number for divisibility by 2, 3, 4, 5, 6, 8, 9, 10, and 11. So here's our number that we're going to be working with. I'm going to call it n just because in certain cases it's going to be easier if I just abbreviate it. All right, so one way to approach this is not to actually go in order by the way that I listed them, 2, 3, 4, 5, 6, etc., but to actually group things together based on the divisibility rules that we're going to use. And so for my divisibility test, I'm going to group together and first do the numbers 2, 5, and 10. The reason I'm going to group these together is because for each of these numbers, to test for divisibility, I just look at what's in the units digit. So in this case, I'm just going to be looking at this number 5. So we know that a number is divisible by 2 if that units digit is even. And so in this case, our number is not divisible by 2. And for a reason, we could write the units digit is not even. Okay, so now let's move on to 5. So now we're still going to look at our units digit. We see that it is a 5. And so we know that, yes, this whole number n is divisible by 5 because the units digit is divisible by 5. So again, all we need to do is look at the units digit to determine divisibility. All right, so our last one in this grouping is 10. We know that a number is divisible by 10 if the units digit is divisible by 10. So what that means is that the units digit is going to be a 0. In this case, so we look again at the units digit, we see that it's a 5, and so our answer here is no. It is not divisible by 10 because the units digit is not 0. Okay, another way that we could actually approach 10 is we could know that the answer is no. And the reason that we could give is because we already know that it's not divisible by 2. And since 2 divides 10, our number cannot be divisible by 10, because if it was divisible by 10, it would also have to be divisible by 2. And so I could write, because 2 divides 10, so remember this vertical line here, this means divides. So 2 divides 10, but 2 does not divide n. So this symbol here, where I have the vertical line and I cross it out, this means does not divide. Okay, so that would be a second way that we could say that 10 does not divide the number n. All right, so far we have tested for divisibility by 2, 5, and 10, and we've only gotten a yes answer for 5, so 5 does divide n. Let's move on to our next grouping. So our next grouping is similar in that we are looking at digits, just a couple of digits for our number. However, for this next set of divisibility tests, we are going to look at either the last 2 numbers or the last 3 numbers. And so the numbers we'll test for divisibility by are going to be 4 and 8. And so for 4, we look at the last 2 digits of our number. So I go up to my number, I look, and I see that the last 2 digits are 0, 5. And so that means that the answer here is no. And the reason is because 4 does not divide the number 5 or 0, 5. So these are the last 2 digits. Okay, so then for 8, what we do is we look at the last 3 digits. The last 3 digits are 105, And maybe we need a calculator to check for this, or maybe you use long division, but we could also say, in this case, no, and the reason is because 8 does not divide 105. And so in this case, we're looking at the last 3 digits. Just like above, we could give a second reason for 8. So we could say no, because, so we know that 4 divides 8, but we already determined that 4 does not divide n. Okay, and so if 8 divided n, then 4 would also have to divide n, because 4 divides 8. But since that's not the case, then 4 cannot divide n. Okay, our next grouping of numbers is going to be 3, 9, and 6. So let's look at those. Let's actually put them in order. So 3, 6, and 9. And the way that we approach these numbers, well, let's say the way that we approach 3 and 9 is we look at our number n and we add up all of the digits here. So we're going to add 2 plus 3 plus 1 plus 5 plus 8 plus 9 plus 5 plus 6 plus 7 plus 1, so it's a lot of work, I'm almost done, plus 9 plus 3 plus 1 plus 1 plus 0 plus 5. Okay, so a lot of work. And so when I do that, so let me give myself some more room here. When I do that, I get an answer of 66. And what does that tell me? Well, I know that 3 divides 66, and our divisibility rules tell us that if 3 divides the sum of all of these digits, then 3 also divides n. And so our answer here is yes. And the reason is because three divides 66, and that is the sum of all the digits. Okay, so a little bit more work on that one. The nice thing about this is that even though there is more work to do, once we add up all of those numbers, we have a much smaller number to work with. So dealing with the number 66 is much nicer than dealing with the number n that we started with. Okay, so that's our work for 6. Our work for 9 is similar. So we would again look at the sum. So the sum of the digits is 66. Still, I don't have to do that work again. But 9 does not divide 66. And so that means 9 does not divide n. So 9 does not divide 66. So 9 does not divide n. So for both 3 and 9, we are looking at the sum of all of the digits and then seeing, does 3 divide that sum? And for this case, does 9 divide that sum? Okay, our work for 6 is related to this, but only because in order for a number to be divisible by 6, it has to be divisible by both 2 and 3. So is n divisible by 2 and 3? So it is divisible by 3, we just found that out, but we already decided earlier that it is not divisible by 2. And so since the answer is no for one of these, then the answer overall is that 6 does not divide n. If our number was divisible by both 2 and by 3, then it would be divisible by 6. Okay, moving on to our last one. This one involves the most amount of work. So we're going to check for divisibility by 11. And so what we're going to do is we are going to look at two different sums of digits, subtract them, and then see if that result, that difference, is divisible by 11. And so what we're going to do, so let's go back up to our number here. We are going to, so let me just rewrite it. So our number is the following. So I have 2, 3, 1, 5, 8, 9, 5, 6, 7, 1, 9, 3, 1, 1, 0, 5. And so what I'm going to do is I'm going to add up two different sets of numbers. So for my first set, I'm going to look at digits that are in places that are even powers of 10. So I'm going to start with the first one. So this is the units place. So this is the 10 to the 0 place. And I'm going to take I'm going to jump over. This is the hundreds place, which is 10 to the second. I'm going to keep jumping, doing every other digit until I have nowhere else to go. Okay, so I'm going to add up those numbers. And then the second set of numbers that I'm going to add up, so let me choose a different color. I'll highlight them in pink. So now I'm going to add up digits that are in the places that are odd powers of 10. So my first one will be in the tens place. That's 10 to the first. Next one will be in the thousands place. That is 10 cubed. And then I keep going. Okay, so I'm going to sum up my yellow digits. So 5 plus 1 plus 3 plus 1 plus 6 plus 9 plus 5 plus 3. And I'm going to subtract off the sum of the pink digits. So 0 plus 1 plus 9 plus 7 plus 5 plus 8 plus 1 plus 2. Okay, and so what does this equal? So I get 33 for the first sum. I also get 33 for the second sum. So overall, that gives me 0. And I know that 11 divides 0 because every whole number divides 0. Or you can also say this as 0 is divisible by every whole number. And so what this means, or what we can conclude, is that yes, our number is divisible by 11, so 11 divides n. Okay, so overall, what can we conclude? So our conclusion from our divisibility tests is that what numbers divide n? So we found that 5 divides n. We found that 3 divides n. And we found that 11 divides n. So these are the three numbers that we found divide n.